Hello, this is Team 1's final project presentation. My name is Georgia Maroulis, and I will be discussing the answers of questions 1, 2, and 6. So we start with the first question, which has to do with loading the graphs from the Edge file into GraphG. We do so in this section here and present information about it, which, as one can see, shows that the graph has 34 nodes and 78 edges. We then plot the graph, and it ends up looking like this. For question 2, we wanted to figure out who is the most popular member in the club. To do this, we find the node with the largest degree, which is equivalent to the popularity, and find out that it is members 33. Next, Sarah Stebbins will discuss question 3.
So for question 3, we will need to plot the network of nodes based on their node degree. First, we input the necessary dimensions here and the layout that we want to view the graph in. Then we will sort the nodes into their lists based on their degree here, less than 3, greater or equal to 3, and less than or equal to 8, and greater than 8. Then we will use a for loop and an if statement to iterate the nodes and assign them their respective colors to each of their degree-based node list. And then the result, we'll do that for each color here, green, yellow, and red. The result here will be an undirected graph where all the nodes with the same node degree are connected to each other by paths, and they are represented by their assigned color.
Good day, everyone. My name is Jimmy Allen, and today I'm going to cover question 4 in our final project. Question 4 states that student 16 wants to reach student 26 through the shortest path. The second part of question 4 is to plot the shortest path in red color between student 16 and 26. Now, to find the shortest path in this undirected and weighted graph, the first step is to load the graph from the edge list as shown in line 1. On line 2, we calculate node positions using NX string layout from the nodes in the undirected graph from line 1. Moving to line 3 codes, we need to find the shortest path between student 16 to 26. To do that, we need help from NX shortest path. We then pass our graph and we set the source and the target node. So basically, the shortest node is starting from student 16 to find the shortest path to student 26. In line 4 code, we print the results from the undirected shortest path, which is 16, 5, 0, 8, 33, and 26. And this is the shortest path from student 16 to 26. The second part of question 4 is to plot the shortest path in red color between student 16 and 26. To do that, we use the code in line 5, which is NX draw network, to plot the original undirected graph first at the bottom layer, and then we draw the shortest path nodes in line 6 codes in red color.
My name is Haley Booth, and I will be addressing question 5. So question 5 states that we will assume a company wants to promote a new product or service to the students within this club, and they want to do so efficiently. So which students should they target in order to be able to do this, and why? In order to do this, we're going to look at which nodes or students in the club have the highest degree of betweenness centrality. This essentially means which nodes or students have the most number of connections to the other ones. So by running this code and determining betweenness centrality, we'll plot the graph, and then we will highlight the nodes with higher degrees of betweenness centrality, with larger size nodes on the graph. So we can visually see that 0 and 33 have the most connections to other nodes. So those students have the most connections to other students in the club. So by picking these two nodes here, 0 and 33, the company will effectively be able to market to these two students because essentially the information will be able to flow to the other students in the club or nodes in the network, as we see here in the graph.
So now I will talk about question 6. Our first question is to find the amount of communities in this network, which by using the formula, we find out that there are 3 communities. Then we edited the colors and the shapes of all the nodes within a specific community to distinguish between each other. And after we've done that, it appears like this. The last one is to find the center of each community. To do so, we created subgraphs for each community and then found out which node in each had the largest degree, which would represent the central one. The results ended up being, for community 1, it was node 33, for community 2, it was node 1, and for community 3, the center node ended up being node 0. That's the last question. Thank you for listening to our presentation.